Hello everybody and welcome to example 5 at the top of page 115 in the workbook. And this example asks us to calculate an integral, particularly the integral of 3x squared times cosine of x cubed. We want an antiderivative for that function. Okay, and the first comment I want to make before we do this is to sneak a peek at the list of common antiderivatives that we already know. Okay, let's make that a little bit bigger. Okay, notice that these are 8 formulas that help us to find antiderivatives, but that the function that we just looked at on the previous page is not one of these 8 formulas. That function in example 5 is too complicated, it's not on our list, and so this table of formulas is not going to help us. Okay, so back to the problem at hand. Notice that they're asking us to use something that's called the substitution rule to do this. And what the substitution rule is it's a way of taking an integral like this that's complicated and transforming it into an easier integral where we can maybe use that table that we just looked at a minute ago. Okay, so here's how it works. We're going to start by making what's known as a substitution. Okay, and the substitution I'd like to make in this case is to let u be x cubed. Notice that that u is just the inside of our cosine function. Okay, you might recognize that as the same kind of choice for u you might make if you were doing a derivative using a chain rule. And after we make that substitution, here's the first thing we're going to do. We're going to take the derivative of that u, du dx. Okay, the derivative of x cubed using the power rule is just 3x squared. Okay, and the next step here is going to seem a little bit unusual the first time you see it. So the du dx that we have, think of that as a fraction, du over dx. If you think of it that way, it becomes possible to multiply both sides of that fraction by dx, the denominator. Okay, we do that as a way of getting rid of the dx over on the left-hand side, and that turns this equation into a new formula, an equivalent one, that looks like du equals 3x squared dx. Okay, then we're going to do one more algebra step. To get the dx by itself, we're going to divide both sides by 3x squared, and that's going to turn into du over 3x squared equals dx. Okay, and so the two things I'd like to focus on in those calculations are this, our choice of u, and the dx that we just calculated that kind of came from that choice of u. All right, so back to the integral that we're trying to do now. I'm just going to rewrite it. So the integral of 3x squared cosine of x cubed. And what we're now going to do is to substitute those two things in, okay, that we just underlined in green here. Okay, so if you look at the x cubed, that was equal to u. That was the substitution that we made. And the dx, you can look and see that that's equal to du over 3x squared. So we just substituted those two things in that we did in our calculations above. Okay, so if we rewrite our integral with those two substitutions, here's what it looks like now. 3x squared cosine of u times du over 3x squared. Okay, do you notice anything algebraic that we can do to simplify here? Well, this 3x squared occurs once in the numerator and once in the denominator, and that cancels. And so what our integral looks like is cosine of u du. That integral is equivalent to the integral that we started with, and notice that it's a lot simpler. Okay, we've got a different variable in our integral, but integral of cosine u du, that function's a lot simpler than what we started with. Okay, can we find an antiderivative for cosine of u? Okay, well, let's sneak a peek at our table again. And notice that formula 3 here tells us that an antiderivative for cosine of x is sine of x. Okay, that's the exact problem that we want to do. We're just using the variable u, so the antiderivative of cosine of u on the previous page should be sine of u. All right, if we write that down, here's what we get. Okay, the plus c is just because we're talking about general antiderivative. And the last step here might be to notice that u is a variable that we kind of invented in the problem, so we should really get our answer in terms of x, and we can do that by remembering that u is really equal to x cubed, so we'll just substitute back again. Okay, and that should be the answer to our problem. Okay, could we check that answer? Okay, well remember that what we just calculated was an antiderivative, so we could check it by taking the derivative of our answer and seeing if it takes us back to the function that we integrated. All right, so what would we get if we took the derivative of sine of x cubed plus c? Well, the plus c, that's going to go to 0 because it's a constant. And the derivative of sine of x cubed, we can take that derivative using the chain rule. So we would get cosine of x cubed times the derivative of the u, which is 3x squared. And notice that that function that we got agrees with the function that we started with inside of our integral. That confirms that our answer up here is correct.